So now all we have to do is plug these in here. So for the lead, I'm going to plug in 2 times 10 to the negative 4, and I'm going to raise that to the first. And then for the iodide, I'm going to plug in 1.6 times 10 to the negative 2, and I'm going to raise that to the second. Now before I throw this in my calculator, I want to ask you a question. Am I calculating K here? No, Paul, that was your first instinct. You're like, no, you're not. These are just any old concentrations. I have no idea if they're at equilibrium. I have no idea if my solution is saturated. That's kind of what we're trying to figure out. So when you plug numbers into a K expression, but it's not at equilibrium, what are you figuring out? What do we call that? Someone say it louder.
Q.
We're figuring out a Q. So this is really a Q. All right, what did you guys get? Did anybody already get the answer?
7.8 times 10 to the negative 5.
5.12.
I think I'm getting that second one.
Yeah.
Did
you square it?
Okay. Did you square it?
Yeah.
Try it one more time. You got to square the 1.61. Just try it one more time. So I'm getting 5.12 times 10 to the negative 8. That's the Q value. Okay?
What is Q representing? Just like the plum?
It's just a product.
Okay.
Okay? But here's the deal. Remember what we said before? If these ions are smaller than what fits, then there's no precipitate because there was room. But if they're bigger than what fits, then those extra ions will precipitate out. So what I'm going to do is I'm going to compare this Q to the K value. I had the K value written earlier. Let me write it again. The KSP for lead iodide wasn't it 7.1 times 10 to the negative 9?
Yeah.
7.1 times 10 to the negative 9. Okay, so, let's erase this. Okay, so if K is 7.1 times 10 to the negative 9, and if our Q is 5.12 times 10 to the negative 8, how does our Q compare to the K?
Precipitate won't form.
Q is what?
Smaller.
It's bigger.
Oh, bigger. Right.
So if Q is bigger, then you've gone too far, haven't you? We have too many ions. So it has to back up. When it backs up, what happens? A precipitate occurs. Does everybody get that? Now, if Q is less than K, or even exactly equal to K, will a precipitate occur? No, no precipitate occurs. Because you can still fit more. But the answer to this problem was yes, a precipitate occurs. Someone had their hand up. Yes, Summer.
So if the exponent is less than the original, precipitate will form.